Top 25 Petroleum Engineer Interview Questions and Answers. Petroleum engineering is a demanding and technically complex discipline that focuses on the exploration, drilling, production, and management of oil and gas resources. Professionals in this field must combine engineering knowledge with geology, economics, safety, and environmental responsibility. Interviewers seek candidates who demonstrate strong technical fundamentals, problem-solving ability, teamwork, and adaptability to industry challenges. Preparing consistent, detailed answers help show confidence and professional maturity. The following top 25 petroleum engineer interview questions and answers are designed to help you communicate your knowledge clearly and perform successfully in a competitive interview environment. 1. Why did you choose petroleum engineering as your career? I chose petroleum engineering because it combines engineering principles, geology, and advanced technology to solve complex real-world energy problems. I am interested in how reservoirs are analyzed and how innovative drilling and production techniques maximize recovery. The field offers challenging work, continuous learning, and global career opportunities. I am also motivated by the responsibility petroleum engineers have to ensure safe, efficient, and environmentally responsible energy production while adapting to evolving industry demands and sustainability goals. 2. What are the main responsibilities of a petroleum engineer? The main responsibilities of a petroleum engineer include evaluating reservoirs, designing drilling and production systems, and optimizing hydrocarbon recovery. This involves analyzing geological and production data, selecting equipment, monitoring well performance, and implementing enhanced recovery methods. Petroleum engineers also ensure safety compliance, manage costs, and minimize environmental impact. Collaboration with geologists, drilling teams, and management is essential. Overall, the role focuses on maximizing production efficiency while maintaining safety, profitability, and regulatory compliance. 3. What is reservoir engineering? Reservoir engineering focuses on understanding how fluids, such as oil, gas, and water behave within underground reservoirs. It involves estimating reserves, analyzing pressure and flow behavior, and forecasting production performance. Reservoir engineers use mathematical models and simulation software to design optimal recovery strategies. Their work supports decisions related to well placement, production rates, and enhanced recovery methods. Effective reservoir engineering helps maximize hydrocarbon recovery while reducing operational risks and improving long-term field performance. 4. Explain the difference between upstream, midstream, and downstream sectors. The upstream sector focuses on exploration and production, including drilling and reservoir management. The midstream sector handles transportation, storage, and processing of hydrocarbons through pipelines and terminals. The downstream sector involves refining crude oil, processing gas, and distributing finished products such as fuels and petrochemicals. Petroleum engineers primarily work in upstream operations but benefit from understanding all three sectors to appreciate how technical decisions affect the entire energy value chain and overall profitability. 5. What drilling methods are you familiar with? I am familiar with vertical drilling, directional drilling, horizontal drilling, and multilateral drilling. Horizontal and directional drilling are particularly effective for maximizing reservoir contact and increasing recovery rates. I also understand offshore drilling operations and the use of drilling rigs, mud systems, and well control equipment. Selecting the appropriate drilling method depends on geological conditions, reservoir characteristics, cost efficiency, and safety considerations. Proper planning ensures efficient and safe drilling operations. 6. What is enhanced oil recovery, EOR? Enhanced oil recovery refers to methods used to extract additional oil after primary and secondary recovery stages. Common EOR techniques include thermal recovery, gas injection, and chemical flooding. These methods improve reservoir pressure or reduce oil viscosity to increase flow. EOR plays a critical role in extending field life and improving recovery factors. Proper technical and economic evaluation is essential to ensure feasibility while minimizing environmental impact and operational risks. 7. How do you ensure safety in petroleum operations? I ensure safety by strictly following industry standards, company procedures, and regulatory requirements. This includes conducting risk assessments, using proper personal protective equipment, and participating in safety training programs. I believe in proactive hazard identification, clear communication, and teamwork. Regular inspections and emergency preparedness are also important. Maintaining a strong safety culture protects personnel, equipment, and the environment while ensuring smooth and uninterrupted petroleum operations. 8. What software tools are you familiar with as a petroleum engineer? I am familiar with reservoir simulation tools such as Eclipse and CMG, geological modeling software like Petroleum, and production analysis tools. I also use Excel and programming tools for calculations and data analysis. These tools help evaluate reservoir performance, optimize production strategies, and support decision-making. I am always willing to learn new software as technology evolves, ensuring efficiency and accuracy in petroleum engineering tasks. 9. How do you evaluate reservoir performance? Reservoir performance is evaluated by analyzing production data, pressure behavior, and fluid movement. I use decline curve analysis, material balance calculations, and simulation models to compare actual performance with predictions. Monitoring trends in pressure, oil, gas, and water production helps identify issues early. Regular evaluation supports decisions on well interventions, enhanced recovery techniques, and long-term development planning to maximize recovery and efficiency. 10. What is the role of geology in petroleum engineering? Geology provides a foundation for petroleum engineering decisions by describing reservoir structure, rock properties, and fluid distribution. Geological data guides well placement, reservoir modeling, and reserve estimation. Close collaboration between geologists and petroleum engineers reduces uncertainty and operational risk. Understanding subsurface conditions improves drilling success, production efficiency, and overall field development planning, making geology essential to petroleum engineering success. 11. How do you handle high-pressure work environments? I handle high-pressure environments by staying organized, calm, and focused. I prioritize tasks, rely on data-driven decisions, and communicate clearly with my team. Pressure is common in petroleum operations due to safety, cost, and time constraints. Proper planning and teamwork help manage challenges efficiently. I view pressure as motivation to maintain discipline, accuracy, and professionalism while ensuring safe and effective operations. 12. Explain the importance of well testing. Well testing provides critical information about reservoir properties, pressure behavior, and production capacity. It helps identify formation damage, flow restrictions, and reservoir boundaries. The data supports decisions related to completion design, stimulation, and production optimization. Accurate well testing reduces uncertainty, improves reservoir understanding, and enhances long-term field performance by enabling informed engineering decisions. 13. What is drilling mud and why is it important? Drilling mud is a fluid used during drilling to cool the drill bit, remove cuttings, control formation pressure, and stabilize the wellbore. It also prevents formation fluids from entering the well. Selecting and maintaining proper mud properties is essential for safety and efficiency. Incorrect mud design can cause well control problems, formation damage, or equipment failure, making mud management a critical drilling responsibility. 14. How do you manage production optimization? Production optimization involves analyzing well and field data to improve output and reduce operating costs. I evaluate flow rates, pressure trends, and equipment performance to identify inefficiencies. Adjusting operating conditions, scheduling maintenance, and applying enhanced recovery techniques help improve production. Continuous monitoring and collaboration with operations teams ensure production targets are achieved safely and efficiently. 15. What challenges do petroleum engineers commonly face? Petroleum engineers face challenges such as reservoir uncertainty, fluctuating oil prices, environmental regulations, and operational risks. Managing mature fields and controlling costs while maintaining safety is demanding. Engineers must adapt to technological changes and evolving energy policies. Strong problem-solving skills, flexibility, and continuous learning are essential to overcoming these challenges and maintaining efficient, sustainable operations. 16. How do you ensure environmental compliance? I ensure environmental compliance by strictly following government regulations, company policies, and industry best practices. This includes proper waste management, spill prevention measures, emissions monitoring, and environmental impact assessments. I stay updated on environmental laws and ensure that operations meet required standards. I also support the use of environmentally responsible technologies and report any environmental risks immediately. Responsible environmental management protects ecosystems, maintains regulatory approval, and supports the long-term sustainability and reputation of petroleum operations. 17. What is hydraulic fracturing? Hydraulic fracturing is a stimulation technique used to enhance permeability in low-porosity reservoirs, particularly shale formations. It involves injecting high-pressure fluid into the rock to create fractures that allow hydrocarbons to flow more easily into the wellbore. Proper fracture design, fluid selection, and monitoring are critical to ensure efficiency and safety. When managed responsibly, hydraulic fracturing significantly increases production and makes previously uneconomical reservoirs commercially viable while adhering to environmental and safety standards. 18. How do you work with multidisciplinary teams? I work with multidisciplinary teams by maintaining clear communication, mutual respect, and shared objectives. Petroleum engineering projects require close coordination with geologists, drilling engineers, production teams, and management. I actively share data, participate in discussions, and value different technical perspectives. Collaboration improves problem-solving and decision-making. By aligning goals and responsibilities, multidisciplinary teamwork ensures projects are executed efficiently, safely, and within budget while achieving optimal production results. 19. How do you handle field data analysis? I handle field data analysis by first verifying data accuracy and organizing it systematically. I analyze production rates, pressure trends, and fluid behavior using software tools and spreadsheets. Comparing real-time field data with simulation models helps identify deviations and potential issues. I document findings clearly and communicate results to relevant teams. Accurate field data analysis supports informed decisions, improves reservoir management, and helps optimize production performance over time. 20. What is decline curve analysis? Decline curve analysis is a method used to predict future oil and gas production based on historical production data. By analyzing decline trends, engineers estimate reserves, forecast field life, and evaluate well performance. This technique supports economic evaluation and development planning. Decline curve analysis is especially useful when detailed reservoir data is limited, making it an essential tool for long-term production forecasting and decision-making. 21. How do you manage project costs? I manage project costs by careful planning, continuous monitoring, and evaluating cost-effective alternatives. I balance technical requirements with economic feasibility while maintaining safety and quality standards. Regular cost tracking helps identify potential overruns early. Collaboration with procurement and operations teams ensures efficient resource use. Effective cost management improves profitability, supports sustainable operations, and ensures projects are completed within budget constraints. 22. What role does technology play in petroleum engineering? Technology plays a crucial role in improving exploration accuracy, production efficiency, and operational safety. Advanced reservoir simulation, automation, and data analytics help optimize decision-making and reduce uncertainty. Digital monitoring systems improve real-time control of operations. Adopting new technologies enables cost reduction, enhanced recovery, and environmental protection. Staying updated with technological advancements ensures petroleum engineers remain competitive and capable of handling complex energy challenges. 23. How do you handle uncertainty in reservoir data? I handle uncertainty in reservoir data by using probabilistic models, multiple scenarios, and sensitivity analysis. I continuously update models as new data becomes available and collaborate with geologists to refine interpretations. Risk assessment helps guide decision-making under uncertainty. Flexibility and adaptive planning reduce potential negative impacts. Managing uncertainty effectively improves reservoir development strategies and supports more reliable production forecasts. 24. What qualities make a successful petroleum engineer? A successful petroleum engineer is analytical, adaptable, safety-conscious, and ethical. Strong technical knowledge, problem-solving skills, and attention to detail are essential. Effective communication and teamwork enable collaboration across disciplines. Continuous learning helps engineers adapt to technological and industry changes. A commitment to safety, environmental responsibility, and efficiency ensures long-term professional success and sustainable petroleum operations. 25. Where do you see yourself in 5 years as a petroleum engineer? In 5 years, I see myself in a senior technical or field development role, contributing to major projects and mentoring junior engineers. I aim to deepen my expertise in reservoir management and production optimization. I want to support efficient, safe, and environmentally responsible energy production while advancing within the organization. Continuous learning and leadership development will help me add long-term value to the company. Petroleum engineering interviews evaluate technical knowledge, safety awareness, adaptability, and problem-solving skills. Providing consistent, well-structured answers demonstrates professionalism and readiness for industry challenges. Emphasizing reservoir understanding, production optimization, teamwork, and environmental responsibility strengthens your candidacy. With thorough preparation and confidence, you can present yourself as a capable petroleum engineer prepared to contribute to safe, efficient, and sustainable energy operations.